Hello everyone, welcome to my presentation on rock mass classification and rating systems used in rock mechanics. Our study area is Bukit Ayam, where we conducted detailed fieldwork involving data collection and analysis. In our study, data collection focuses on three main methods for assessing rock mass quality and slope stability. First, the Rock Mass Rating, or RMR, is a comprehensive system that evaluates the rock mass based on several engineering parameters. Second, the Slope Mass Rating, or SMR, is derived from the RMR, but specifically adapted to evaluate the stability of slopes by considering the orientation of rock discontinuities relative to the slope face. Finally, kinematic analysis is a method used to analyze the possible failure mechanisms in rock slopes based on the geometry and orientation of joints and discontinuities. Together, these methods provide a holistic view of rock stability in the field. So this is the data of J1 and J2 that gained during the fieldwork. The rock mass rating system involves 6 key parameters that quantify the quality of the rock mass. The uniaxial compressive strength measures the strength of intact rock material, showing how much load the rock can bear before failure. The rock quality designation, or RQD, indicates the degree of jointing or fracturing in the rock mass by measuring the percentage of intact core pieces longer than 100 millimeters. The spacing of discontinuities refers to the distance between joints or fractures in the rock, with larger spacing generally indicating better rock quality. The condition of discontinuities assesses the roughness, weathering, infilling, and other features of the joints that affect rock strength. Groundwater conditions influence rock stability, since water can reduce friction and cause weakening or erosion. Finally, the orientation of discontinuities relative to the excavation or structure is considered because unfavorable joint orientations can lead to instability. Our total rating is 12, while our RMRB is 64. Each parameter is assigned a rating, and their sum gives the overall RMR value. Slope Mass Rating, or SMR, is a classification system derived from the basic rock mass rating, but specifically tailored for evaluating the stability of rock slopes. SMR adjusts the basic RMR by including correction factors that account for the relative orientation between the slope face and the discontinuities, which greatly influence slope stability. The SMR formula is SMR equals basic RMR plus F, 1 times F, 2 times F3 plus F4, where F1 accounts for the parallelism between the slope face strike and the joint strike. F2 relates to the dip angle of the discontinuity. F3 considers the relationship between the slope dip and discontinuity dip. F4 is an adjustment factor based on the method of excavation, such as blasting or natural slope conditions. By applying these correction factors, SMR provides a more accurate assessment of the likelihood and type of slope failure, which is crucial for designing slope stabilization and support. Typically, slopes with SMR values above 75 are stable and require little to no support, while slopes with SMR values below 30 are generally unstable and require remediation. Our SMR plane is 64.13 and SMR topping is 64.11. That means our SMR is quite average. Kinematic analysis is a geometric method used to predict potential failure modes in rock slopes. It examines the orientation of discontinuities, such as joints, faults, or bedding planes, and compares them with the slope geometry to identify possible instability mechanisms. Common failure types include planar sliding, wedge failure, and toppling, which depend on how discontinuities intersect the slope face. By performing kinematic analysis, engineers can anticipate these failure modes and design appropriate stabilization measures.